Assalamualaikum and good afternoon. First of all, really sorry for the delay in preparing the so-called explanation. As you can see, basically, I think this video is purposely, specifically on the error propagation, which, frankly speaking, I didn't cover it last time during the lecture. So, before we go in detail on how to calculate all this, I think better if we can have a look first at the slide itself. Okay. In this case we talk about the error propagation and machine epsilon. So for the uncertainty measurement, there are some parts where we need to there are some values which also include with uncertainty. For example, in this case, the value of absorbance is 0.23, right? But if you put here, this is 0.2, 1, 2, 3, but if you look at the actual measurement, it may be 0.235. The same here with the transmittant, which is here, it's 58. If you look here, it may be 58.5. Look at the close value here. So this uncertainty basically add on the possible plus and minus of the actual value or the measured value at that time. Okay, all measurements have some uncertainty associated with them, and the final answer will of course have some level of uncertainty. So now we talk about the propagation of errors, as one of you actually asked in the WhatsApp group, how to calculate the propagation of error. Right. So in this case, we are given an example of an area of a rectangle where A is equals to L times length times width W. So if L is equals to 5 plus minus 0.2 and W is equals to 2 plus minus 0.2, we need to calculate the error and also its certainty. So in this case, the answer is 10 plus minus 1.1, which is the uncertainty. So how to calculate this uncertainty? So we can go to the next slide. So there are few methods. Rule 1 is the for addition and subtraction. We can actually utilize the calculation here. Secondly, is for the multiplication and division. And thirdly, on the multiplication with a constant. Okay. So how to calculate with this? Right. Let's go back. For the addition, last one will be the raising to a power. So we need to calculate also when it involves power. Okay, let's go back. So in this case, for the addition and subtraction, let's say R is the value that we want to find, and X, Y, and Z is three constant that we're going to calculate to find the answer of R. Therefore, the uncertainty of R, which is the total value here, is equals to approximately equal to delta X plus delta Y plus delta Z, which is the uncertainty of Y, uncertainty of X, uncertainty of Y, and uncertainty of Z. But the actual value is basically square root of square of uncertainty X plus square of uncertainty Y and square plus square of uncertainty Z. So let's see if we are given an example here. Z is equals to X plus Y, where X equals to 3 plus minus 0.1 and Y equals to 4 plus minus 0.2. Okay, let's put it on the side. So basically, let's have a red color. Basically, we know that R is equals to square root of delta X square plus delta Y square. So in this case, X equals to 3.0 plus minus 0.1. So this is x, this is delta x, this is not 8, okay, this is delta x. Y equals to 4.0 plus minus of 0.2. So this is y, is delta y. So in this case, delta r is basically equals to 0.1 square plus 0.2 square equals to, okay, we have a calculator. So after calculating, we will get the value is equals to 0.22. So the uncertainty, the uncertainty of r is equals to plus minus 0.2, which is exactly this. Alright, okay, of course, sorry, in this example this is actually z. Never mind. Okay, let's just erase first this one. Erase the whole thing. We're going to go to another example. Okay, so next is for the multiplication and division. Okay, for this multiplication and division, an example is given here. Basically, it is of if r is equals to x times y over z, so the delta r is equals to, here is basically the magnitude of r times square root of delta x over x square plus delta y plus y over y square plus delta z over z square. So if you're given an example here where a is equals to a lw, so given a is equals to lw, where L is equals to 3.0, oh sorry, it's too far, 3.0 plus minus 0.1, and W is equals to 4.0 plus minus 0.2. So taking from this equation, this is basically L times W. So delta R is sorry, delta A in this case is delta A. So delta A is equals to A times square root of, where is it? Delta x over x, which is in this case 0.1 0.1 over 3 square plus 0.2 over 4 square, which is equals to A, this is 12 times square root of 0.1 over 3 square plus 0.2 over 4 square. So of course use the calculator. So the answer is actually equals to 0.7211, or if you look here it's 0.7, so plus minus 0.7. So that will be the uncertainty for the multiplication. Okay, let's move on to the other one. Okay, the other one will be for the multiplication with a constant. So I think this is quite simple really. So R is equals to C times x, which is c is a constant, x is of course a variable. So delta I equals to magnitude of c times delta x. So f equals to mg. So in this case, for del f equals to mg. So in this case, g is constant. Okay. So what will be the identity for f in this case? So delta f is equals to g times delta delta m. So it's equals to 9.81 times 0 0.05, which is equals to 9.81.05, which is equal to 0.49. Yeah, exactly the same here. So of course this is plus minus. Then we move on to the next one. So next one is basically raising to a power. So r, let's say r is equals to x power of n. So delta r is equals to magnitude of n times delta x over x, magnitude of x, times the magnitude of r. So in this case, let's erase all this first. Sorry. Okay. So let's say you are given z equals to x squared. So where x equals to 3 plus minus 0.1. So knowing that, so delta z will be equals to power of n 2 times delta x over x, which is 0.1 divided by 3 times delta r, which is in this case 3 square times 9, equals to 2 times 0.1 divide 3 times 9 equals to 0.6. Alright, so we have all this solution now. I mean, I've found how to basically solve for all that using this method. So now let's see how we can implement to the problem given before in the homework. Okay, let's go back to the homework and to have a look at this. So in the question 3 for error propagation, A, use ideal gas law to calculate the temperature in Kelvin with its uncertainty of 1 mole of an ideal gas at P equals to 275 kPa and V equals to 12.5 liter. The uncertainty in pressure and volume measurement are 0.04 kPa and 0.005 liter respectively. Take this as a constant as R equals to 8.314 liter per kilopascal over mole, liter kilopascal mole over Kelvin. Okay, now let's basically establish the equation first. The ideal gas formula is basically PV equals to nRT. Of course, you can search it on internet, but coming from you, you are supposed to be you're supposed to remember that. So you are given P is equals to 2750 kPa plus minus of 0.04. Okay, wait. This one should be written on the right hand. Sorry. kPa. So V is equals to 12.5 plus minus 0.005 liter. N is equals to 1 given here, right? 1 mole of ideal gas. So N is the basically in mole. And then R is equals to 8.314. Find temperature with uncertainty. Okay. So in that case, T is equals to PV over NR. So as you can see here, it's all multiplication and division, right? So with that, we can refer back to the equation here. Oh no, yeah. Multiplication and division. In that case, we have to follow this equation, right? So in that case, delta T is equals to T times square root of P. Okay, let's take P first. Delta P over P square plus delta V over V square, and N and R doesn't have value, so you just leave to that. Okay, there's no other uncertainty, only two of that. So delta T is equals to, what is value of T? So we can calculate here. T is equals to PV, which is 275 times 12.5 divided by 1 times 8.314. So T equals to 413 times square root of, in this case, delta P 0.04 divided by P, which is 275 square, equals to 2.1. That's a very small numbers there. 0. Sorry, I think rather than that, I just put the values. It will be easier to calculate later on. So here is basically 0.04 divided by 275 square plus delta V is equal, okay, 0.005 divided by 12.5 square. So delta T is equals to what? Let's calculate properly now. Square root times 0.04 divide 275 square plus 0.005 divided by 12.5 square, okay, times 413. So delta T is equals to 0.1757, or maybe 6. We can do that. Okay, let's look at this question here. Oh, it's not given. But yeah, this is basically the step of finding that. So in the B question, a coin is released from a building to the ground with initial speed. So you need to find the equation which describe that. I think you can refer to one of the note about the acceleration. Okay, I will not solve this. And you can basically utilize it. This one utilize square and so on, something like that. I don't remember that. I don't remember this equation. Okay, now I'll stop here now and then use this as your reference.